Alright guys, welcome back. This is going to be the second video in my channel. This one is going to be a kind of follow-up from last video, which was just generic forces. This one is going to be a forces on an incline. So you're going to see this problem a lot in your Physics 1 classes. You're going to see it a ton. So basically what you have is a box or some kind of object on an incline right here that is they'll give you the angle. They'll give you the angle that the incline is at, which this one I have it at 30 degrees. So basically, and then they're gonna give you they're gonna say, oh hey, there's a guy on this side pushing the box up the incline. They're going to ask you, what force does this guy need to be pushing to keep this box from sliding down? So basically what you're solving is, at what force does this guy need to push at in this direction to keep this box still? Not moving it forward, not moving it back, not letting it slip and fall, but just to keep it still. No acceleration. The whole right side of the sum of Newton's second law is equal to 0, basically. Also, they're going to say, hey, this box weighs, I don't know, let's say 10 kilograms. Just throwing a number out there. 10 kilograms. That box weighs 10 kilograms. So basically what you want to do first is draw out a free body diagram. You can use this same picture if you wanted, but I like to draw it out again sometimes. That way you can get a clearer look. So basically the forces acting on this are going to be the guy who's pushing up the box up the incline in that direction. Then you have the weight of the box, which is acting downwards. It's going to act on the center of the box, the center of the mass of the box, and it's going to act downwards. So let's call this the force of gravity, and let's just call this Fm for the F of the man, for the force of the man. All right, so basically now what you need to do is set up your coordinate system. The best way to do it is with these problems, you don't want to say that's the x direction and that's why. You don't want to do that. The best way to do it, the easiest way, is say you want to put the x direction, or any one of your directions, whatever you feel comfortable with, in the direction of the incline, like that. So we're going to say x and y, just like that. So x is going to be parallel. One of your directions will be parallel with the incline. From then on, now, we're going to break up these forces into components of the x and y coordinate system and plug them into Newton's second law, which is we're going to sum the forces and set them equal to 0 to find the force that this guy needs to be pushing at to keep this box stable and not moving. So let's start off with breaking down the force of the gravity into x and y coordinates. Okay, so this is what I do. There's other ways to do it. There's whatever you feel comfortable with. Breaking it down into components. I draw the coordinate system that I have set out. So there's my x coordinate, and there's my y coordinate, just like that. Then we have the force of the gravity acting in the downward position like that. So force of gravity here. Then, so this, since this incline was at a 30-degree angle with the ground, we're going to do just simple trig here. So this is a 30-degree angle. Therefore, since this is a 90-degree angle, this has to be 60 degrees right here. Just like that. And then, so now that you know this angle, you can use this angle and use your trig functions, your sine, cosine, tangents, to find the x component and the y component of the force of the gravity. So to find the x component, which is this direction of the force of gravity, use your trig functions, look at this angle right here. Okay, so Katoa, we're going to use cosine because this is the adjacent component right here. So basically what you get is cosine of this angle, which is 60, is equal to, we're going to call this the fx component, fx over the hypotenuse, which is the force of the gravity. Okay? So then, once you're there, you know this angle. So solving for fx, you get fg, force of the gravity, times cosine 60. All right, then once you get that your fx is equal to the force of the gravity times cosine 60 through the diagram here, now since we know what this force of the gravity is, we can solve for the force of gravity with the given weight up here. So basically the force xg, let's call it, they're both the force of the gravity in the x direction, is equal to the mass times the gravity times cosine 60, because since Fg is equal to mass times gravity. Okay? Then, now that we know the force of gravity in the x direction, we don't really need to solve for the force in the y direction, because since all the other forces are in the x direction, you're not going to have another force in the y direction, so it's kind of irrelevant. Because the force of the man is only in the x direction, all we needed was the x component of the gravity force. Let's say if this guy's force came in at an angle, then you would need both the x and the y to solve for both the x and y component of the man's force. But since his force is only in the x direction, all we need is the x component of the gravity force. So all we're going to do is we're going to sum our forces just like we've done before, equal to 0. Let's call them sum of the forces in the x direction, since that's what we're dealing with. So we're going to start off in the x direction. We have the force of the man, but that's negative since he's going in the opposite direction of the x coordinate that I set up at the beginning of the problem. Then we have the x component of the gravity force, so we're going to call that fxg. And since here you can see that the x component goes parallel with the x coordinate system in the positive direction, that's going to be positive. We're going to set that equal to 0. Then all you got to do is plug in what we've solved for already. So you get plus mg cosine 60. Then all you got to do, since we're trying to find our unknown is the force of the man, we bring him over here and we get the force of the man is equal to mg cosine 60. So that, once you know that, you can just plug in the weight, the mass of the box. We know that the acceleration of gravity is 9.81, and then multiply that times the cosine of 60, and that will give you the force that the man needs to push in this direction to keep this box in equilibrium, static equilibrium, basically just to keep it there. So yeah, what they'll make these problems a little bit more difficult by adding other forces and things like that. The most common thing that they're going to add is friction between the box and the incline here. I'll do another problem in another video that adds friction here. I'll do the same problem, but I'll just add friction also. So that'll add, and basically all that's going to do is add. It's going to add another force into our equation. So yeah, if you guys want any other videos on any other topics or anything math, physics, or mechanical engineering or engineering related, you guys can send me a comment or send me a message or put a comment, and then like and subscribe. Thanks guys.